want to give you the following. This is a test question. So I'm going to give you a couple of optimization problems, and we're going to move on to another topic. So the optimization, let's start with this example. Let's say that you have a length of string, and let's say this length of string is measured by L, and we need to cut it into two pieces that are used to make a circle and a square. So a length of string L is cut into two pieces that are used to make a circle and a square. Our job is to find the length of a cut that minimizes the combined area of the circle and the square. So let's write it. Find the length of the cut. We call it X, that minimizes the combined area of the circle and the square. When we go through a problem like this, we need to recall something I showed you yesterday. Is Polya's solution steps. Polya, the Hungarian mathematician that focuses work on problem solving, and they said that whenever we solve a word problem, we have to go through the following steps. The last two steps are particular to optimization, but the first three are true in general. First thing, we need to fully understand the assignment, and to do so, we need to read it very carefully or listen very carefully. And then the next step is we need to visualize the assignment. This is if it's applicable. If it involves a sketch then or a graph, then we need to draw it. And then we need to assign variables to both known and unknown quantities. Then we need to determine the target function, the function which we need to minimize or maximize. So now this becomes specific to optimization. And lastly, we need to find the absolute maximum or the absolute minimum, and recall that in order to do so, we need to examine the endpoints, if there are endpoints, and of course the critical points. Okay? So we'll follow this idea in solving this particular problem. So we read it carefully, we understand that we have a length of a string, we cut it into two pieces, we use one piece to make a circle, we use another piece to make a square, and we need to find the length of the cut that minimizes the combined area. So let's draw a sketch here and see if you can figure out what's going on. So here's the string, and the length of the string is known. Let's call it L. Later on, we can assign a number, a specific number to it. It can be 100 centimeter, 1 meter, or 40 centimeter, and so on. Okay? And somewhere here we cut it, right? And then we have now two pieces. One piece is the length of X, and the other piece has a length of L minus X. Okay? Now, we take the first piece and we make a circle. And we take what's left, L minus X, and then we make a square out of it. Okay? So the area of the circle is pi r squared, and the area of the square is a squared, a being the side. Okay? We can write it actually below. A circle is pi r squared, and a squared is a a squared is a squared. Well, the area of the square is a squared. Now, and of course the combined area would be a circle plus a squared. Now, what is the, how we express r, the radius, in terms of the length x that make up the circle? Well, x is the circumference of the circle, right? So x equals the circumference. So x equals 2 pi r, and therefore r by itself is x divided by 2 pi. And therefore now the area of the circle will be pi r squared, or it will be pi times x over 2 pi squared, like so. And if you clear the parentheses, you end up having x squared on top and 4 pi at the bottom. Again, we have 4 pi squared, but we reduce pi over 4 pi squared to get 1 over 4 pi. So we got the area of the circle in terms of the length of the curve x. Likewise, we're going to say that the perimeter, we use the length of the second piece, L minus x, to make the perimeter of the square. And the perimeter of the square is simply the 4 sides, 4a. So from these relations, we get that a, the side of the square, is L minus x divided by 4. And therefore, the area of the square is a squared, so L minus x over 4 squared. Okay? And we can either clear the parentheses or leave it as it is. And the target function, a, is the combined area. A circle plus a squared, like so. This is the target function. So I'll give you a second to catch up with my writing. All right. So let's write the target function, okay? Well, a circle is x squared over 4 pi, and a squared is L minus x over 4, all of it is squared. So, you know what, this is an important function, so let's frame it. We're going to go back to it. Do you need the previous page back? What, you didn't take the course of speed writing? All right, so now what is it that we want? We want to minimize this area, so we need to look at the endpoint. This is a function in x. X can be any number between 0 and infinity. Remember, so x, let's write it here, x goes from, I'm sorry, did I say 0 infinity? Of course not, 0 and L. Okay, what does it mean x equal 0? So let's look at the endpoints. Okay, remember, we need absolute minimum, so we need to look at the endpoints as well as critical numbers. So when x equals 0, it means that we have no circle. Okay, x equals 0, we take the whole string and make a square out of it. Okay, so it means that no circle, only square. So if x equals 0, then a of square will be simply L squared over, again, x equals 0, so you end up having L squared over 16. On the other hand, if x equals L, it means no square, only circle. And this is the area of the circle, so we have a circle equal L squared over 4 pi. Okay? No, x equals L, so L squared over 4 pi. Now, of these two quantities, which one is smaller than the other? Remember, we're looking for the minimum. Is it the square or the circle? Which area is less than the other? The circle is greater than the square, actually, because 16, the denominator, is greater than 4 pi. Okay? So we divide by greater numbers. So turn out that a square, the area of the square, is less than the area of the circle. So if only the two were in competition, we choose x equals 0 as our solution. But now we need to look at the critical numbers. So we check the endpoint, and now we need to check critical number. To do so, we need to take the target function and the derivative of the target function. So let's see what we have. The derivative of x squared over 4 pi is 2x over 4 pi, or x over 2 pi, right? And now the derivative of L minus x over 4 squared. If you take the quantity inside the parentheses and call it u, then this will be u squared. And therefore, the derivative will be 2u, or 2 times the quantity L minus x over 4. But now we need to look at du dx, the derivative of L minus x over 4. Well, the derivative of L is 0. The derivative of negative x is negative 1. Divide by 4. So we need to multiply everything by negative 1/4, and we set it to equal 0. Look at this. This is really the difficult part. Well, it's not difficult, but this is where we apply the calculus portion of this problem. And then we simplify it and we say x over 2 pi. And here we have negative. And we see we have 16 in the denominator, but we have 2 on top. So it will be L minus x over 8. Again, negative because we have negative 1/4. And all of it equals 0. And at this point, you can decide whether you want to have a common denominator, or I think it will be easier to solve a proportion by cross multiplying. For instance, instead of using common denominator, which will be 8 pi, I can say the following, that x over 2 pi equals L minus x over 8. And then if you do cross multiplication, you get 8x equals 2 pi L minus 2 pi x. You all see that? So I need to solve this part, and I can divide everything by 2 and get 4x and plus pi x, moving the x to the left, and after dividing by 2 equals pi L, and then you have the common factor x here, and you end up having x equals pi L over 4 plus pi. So this is the critical number, right? The problem is, it's not that easy to calculate A for this value. I mean, we can do it, but it's involved pain and suffering. So what do we do next? Well, we can give L a specific value and then figure out, and then maybe we can graph the function for a specific value of L and see if the point in the middle will be lower than the end points.